4.4. Calculate the length of OS. So let's go look what OS is. OS is this length over here. So one thing we can tell from this, which is very important because it does pop up a lot, is this is a straight line. And if you were then to drop the height to the x-axis, we would then be dealing with, and I hope you can see, a right angle. And when there's a right angle, we think of Pythagoras. Like so. So I suspect that we are going to be using Pythagoras somehow in this question, in fact. So let's see how we can do that. Well, we don't have the OS coordinates, so maybe that's a good place to start in order to find the length. So let's try find the coordinates. If we know that OS lies on the straight line y equal to x, and we do know, because it has been told, that it also lies on the hyperbola, which has the... Now, I mustn't get confused between the one we just calculated. Lies on the hyperbola x plus 1 plus 1. Then, if I sum solve these, so I sub in y equal to x into my hyperbola, I can find the x and y values for point S. So let's do that. If y equals x, sub in, x equals 2 plus x plus 1 plus 1. X squared plus x equals 2 plus x plus 1. Getting rid of the denominator. X squared minus those cancel. 2 plus 1 minus 3 equals 0. Solve for x. X squared equals 3. X equals plus minus 3. Because remember, anything to the power of 2 is always a positive. So x could have been plus or minus. And often, in order to find out if it is plus or minus, we will refer to the problem at hand, the context we are dealing with. And in this case, we know S to be in the positive region of the x-axis, so we do know that indeed we are dealing with a positive x. All right, so we know that in this is very messy now. There we go, it's better. We know that in this region, x is equal to root 3, but we still don't know y. Do we even need y? I don't know. All we've done up until now is find the coordinates of S in order to try to find the length. But remember in the beginning I said this is a right angle. We must recognize it can't just be for nothing. If we did know y, and we knew x, hang on, doesn't that mean we can find the distance OS using Pythagoras? I forget the name of this line in a right angle triangle. X-axis, the y-axis. I forget, but we can find this length over here using Pythagoras. So yes, it is indeed worthwhile finding x. So now let's find y. Oh, and that will be as simple as using this equation, because we can sub back in x over here, and y is equal to x, so y is also equal to root 3 positive. Oops, that looks very terrible. Positive. So we have our coordinates for S. Now it's simply a matter of using Pythagoras. So I'm going to write over here now. Therefore, using Pythag, and you don't have to say this, but it's just good to see it. we can say x squared plus y squared equals, and what is this distance over, what is this line over here? OS. OS squared. X is root 3, so that's just 3. Y is root 3, so that's just 3. OS squared. 9 OS squared. OS equals root 9, which is 3, positive or negative. But once again, a distance can only be positive. So in this context, it is indeed positive 3. I apologize. I have done a arithmetic error. I thought that looked very strange. 3 plus 3 is 6. So OS equals root 6. And in this case, because the distance is positive, it will be positive and not negative. And that is all to it. We have found the distance OS using Pythagoras and subbing in the values y equal to x into, not the values, the equation, doing a sim solve with y equal to x and the parabola. The two graphs they had given us in the very beginning. X-axis, no, y equal to x here, and the hyperbola over here. And the problem has been solved.